on to the continuation of our lesson on radians. We're going to cover a particular type of question here on terminal arms, but in radians this time. So for our first question, we're going to find the coterminal angle of 3 pi over 4 with a domain of negative 2 pi to 2 pi. Then we're going to write an expression for the measure of all possible angles that are coterminal with 3 pi over 4. So to find coterminal angles, if it was in degrees, would add or subtract 360. In this case, because we're working in radians, we're going to add or subtract 2 pi, and then we'll get a coterminal angle. So let's maybe first draw what 3 pi over 4 looks like. And this would be in quadrant 2. From 0 radians all the way to 3 pi over 4 radians will look like this. And that would be your terminal arm. Okay, and then now let's try to find some coterminal angles of 3 pi over 4. If I added 2 pi to 3 pi over 4, we are actually going to get an angle that is larger than 2 pi. So instead of adding 2 pi, in this case, I'll subtract 2 pi. So we have 3 pi over 4, subtract 2 pi, and we need to put this so that we have a common denominator. I can multiply the 2 pi by 4 top and bottom, which is 8 pi over 4. This is then negative 5 pi over 4, and that would be our coterminal angle. So therefore, negative 5 pi over 4 is a coterminal angle. And if you want to find the expression for all coterminal angles, like I said, the rule is that you would add or subtract 2 pi and then you're going to find a coterminal angle. If I want to find an expression that describes all possible coterminal angles out there, I would just take 3 pi over 4, add 2 pi multiplied by some integer k, and state that k is an element of the integers. Because k can be any positive or negative whole number. For example, I can find a coterminal angle if k was negative 1 and then would get negative 5 pi over 4. Or what if I had k is 1, then I have 3 pi over 4 plus 2 pi, and that would be another coterminal angle, but it would be above our 2 pi range. So this one is if we don't really have a range, we just want to know all possible coterminal angles out there. Moving on to the next example, we have a point negative 9, negative 5, and we want to find the angle that it creates from that terminal point from the origin. So we're going to draw the picture first. That's 0 radians, pi over 2 radians, pi radians, 3 pi over 2 radians here. And our angle is what we're trying to find. But we're going to draw our point first. It's negative 9, negative 5. Because our x and y are both negative, we know it's in quadrant 3. So our x is negative 9. Our y is negative 5. So this is where our point is. I'm going to connect it to the origin. So that is our terminal arm. And then we're trying to find this angle here. So if you can see on the side, I kind of have a right triangle going on. I can redraw this. And we have a side 9 here and a side 5 here. This angle inside that triangle is our reference angle. It's going to help us find the actual angle. So the first thing we're going to do is find the reference angle. I'm going to use that blue triangle to help us. Because our sides are 5 and 9, we know it is not going to be from our special triangles. And it also said nearest tenth in the original question, so that means we're going to use our calculator for this. So if I want to find what that angle is, it's going to be opposite over adjacent because I have the opposite and adjacent side. So our reference angle is calculated as tan inverse of opposite, which is 5 over adjacent. Remember when you're putting this into calculator that your calculator is in radian mode. You're supposed to calculate it in radians as described over here. You will lose points if you forgot about that and calculate everything in degrees. So make sure that your calculator is in radians. So I'm going to do tan inverse of 5 over 9. We're going to get 1.460. So great, that is our reference angle. The next thing we're going to do is find the real angle because the real angle is actually in quadrant 3, not in quadrant 1. So to find an angle in quadrant 3, it's usually 180 plus your reference angle, but because we're in radians, this will be pi plus our reference angle, which is 4.602. So that's one answer, because that answer is from the 0 to 2 pi, so that's our positive angle. But if you look at our domain, we also need to consider the negative side. So that means I need to find a coterminal angle for 4.602, and it has to be negative. So I'm just saying note here that this guy is between 0 and 2 pi, and we still need to find the negative 2 pi to 0, 1. So we're going to find the coterminal angle by taking 4.602 and subtracting 2 pi to it, so we can get an angle between negative 2 pi to 0. From here, we're going to get negative 1.681, and this would be the other answer that we have. And this angle again is an angle between negative 2 pi to 0. So those are our two answers that belong into negative 2 pi and 2 pi, and it's also in quadrant 3. Moving on to the third type of question, given that secant theta is 2.5 to the nearest tenth of a radian, determine the values of theta in the domain from negative 2 pi to 2 pi. Again, it says nearest tenth of a radian, which means we are going to use our calculator here. So this is our original question. Secant theta is equal to 2.5. Of course, our calculator doesn't have a secant function in there, but it does have cos, and that is the reciprocal relationship. So we're going to rewrite this as cos theta. But when we do that, we reciprocate the exact value. So instead of 2.5, it's 1.25, because that's the relationship between secant theta and cos theta. The next thing we're going to do is find the reference angle. So we're going to take cos inverse of the exact value, and put that into our calculator, and remember to have your calculator in radian mode when you do so. So 1.159 is our reference angle. Now we want to find any coterminal angles, because we need more than just one angle. We are trying to find angles between negative 2 pi to 2 pi. So we're going to take our reference angle. If I added 2 pi to 1.159, we are going to get an angle that is outside our domain. It's too large, so I'm going to subtract 2 pi here, which is negative 5.124. So these are two answers that we could possibly have. The thing is, do we know what quadrant this angle is actually in? We don't. All we're given that secant theta is positive. So that means that it could be in quadrant 1, but cos is also positive, or secant's also positive in quadrant 4. So the answers that we found before, they're both in quadrant 1. We need to consider quadrant 4 now. So if it's in quadrant 4, it's pretty easy to find because it has the same sort of relationship between the ones we just found. So the one in quadrant 4 would be negative 1.159 and positive 5.124. So this one here comes from 2 pi minus 1.159. That's 2 pi minus our reference angle. That's how we're going to get 5.124. Go ahead and do the try it yourself next, and then when you're ready, press play for the solution. So the try it yourself questions are very similar to the 3 questions we've done before. The only things that's different are the numbers. So we just want to find the coterminal angle of 5 pi over 4 for the first one, and then find all possible angles that are coterminal with 5 pi over 4. Very similar to example 3a, we don't want to add the 2 pi in this situation just because of our domain. If we did that, we'll be outside of our domain, so I'm going to subtract 2 pi from 5 pi over 4 to find our coterminal angle. Then I'm going to multiply 2 pi by 4 top and bottom so I can have a common denominator. Which is negative 3 pi over 4. So that is our coterminal angle within our domain of negative 2 pi to 2 pi. Then for the expression for all possible coterminal angles out there, we're just going to take that angle 5 pi over 4 plus 2 pi times some integer k. So this will say that we can add 2 pi as many times as you want or subtract 2 pi as many times as you want, and we get the coterminal angle. Okay, for part B, looking at -4, -3 as our point. So this point belongs in quadrant 3. Our x is -4, our y is -3. So we want to find the reference angle first. So we'll do tan inverse of opposite over adjacent. So that's tan inverse of 3 over 4. Which is 0.644 as our reference angle. The next thing we're going to do then is find the angle that's actually in quadrant 3, because that is where our point belongs in. So to find the angle in quadrant 3, we're going to take pi and add the reference angle to it. So that is 3.785. Okay. And then that's one answer, but we also can find one more because of our domain. We're looking for a negative angle as well that will fit in between -2 pi to 0. So we're going to find the coterminal angle using the angle we just found. So I'm going to subtract 2 pi to find the coterminal angle to this. And -2.498 is our other angle. So those two highlighted answers are the 2 possible angles that would fit in between -2 pi to 2 pi. Our very last example, we have cotangent theta is equal to -2. And it says the nearest tenth of the radians. So again, we're going to use your calculator. So we're going to rewrite this in terms of tan. And we would just reciprocal our exact value. So this would be tan theta is equal to -1/2 instead. Now we're going to find the reference angle. We don't care about the negative. This negative just tells us that it's in quadrants 2, or it could be in quadrant 4 because tan theta is negative there. But when I actually find the reference angle, I'm not going to put the negative in there. So our reference angle is going to be tan inverse of a half. I'm going to put this into a calculator. Remember to make sure it's in radian mode. It's 0.464. All right, so now our next step, I guess first step was writing into tan. Second step is finding the reference angle. Your third step then is to find our angles in quadrant 2 and also find the angle in quadrant 4. So if it's in quadrant 2, we're going to do pi minus 0.464, which is 2.678. For quadrant 4, it's going to be 2 pi minus our reference angle, which is 5.819. Now we're going to find the coterminal angles of each of them. So these two are part of our solution. We still need the negative ones because of our domain is between negative 2 pi to 2 pi. We find coterminal angles. Here again, we want the negative ones. So I'm going to subtract 2 pi to each angle. So this is for quadrant 2 still. So I'm going to subtract 2 pi to find its coterminal angle. That's negative 3.605. And this will be 5.819 minus 2 pi to get the negative coterminal angle, which is negative 0.464. So these two are also part of our solution. You have 4 answers to this. If you want, you can state your final answer that theta is negative 3.605, negative 0.464, 2.678, and 5.819.